So hello everyone, welcome to our channel Electronics on Wheel. As you know, we are running a series where we are telling about how to read a wiring diagram. You can see in the playlist area. I will give you the link in the description as well. So in the last video of this series, we have discussed about the charging system. And as you know, the charging system plays a very critical role when it comes to the supplying the power supply, and the alternator is the main component of the charging system. So today we are starting a new series where we got many requests from our subscriber that how to develop a component in any OEM, what is the process of that, and that is called the product development. So in this series I am going to explain you about how to do the product development. And to be honest, this is my favorite topic. And in life, if you get the chance to select between wiring harness and product development, so I will always recommend you to choose the product development. And why I am saying this, you will come to know when I will try to explain you the product development. What are the things you have to do in product development? And product development is something which is very evergreen area. You will always get the opportunity. So as we will process further, you will come to know why I am saying so. So let me give you the recap of alternator, uh, which we have discussed, and then we will start the development of this alternator. We will take the alternator. So let me start with the alternator. So alternator is the component which supplies the power to the battery, which is nothing but the charging the battery and the electrical load when your engine is running. So when your engine is not running, then alternator is like a ideal, right? You might be aware the basic function of the alternator, that how it generates the supply or power and which distributed to the battery and the electrical load. So you can see the location of this alternator placed in the car. So and how it is packaged. So alternator is mounted always on a engine with bracket, with the support of bracket. In this slide you can see the alternator has connection, with the pulley, that is called our crankshaft. You see that how it is connected with through the belt to the pulley, and this crankshaft or the engine pulley is going to rotate your alternator, and because of that it is going to generate the electricity, or you can say the DC. So first it creates the AC and then it goes to the DC through the voltage regulator. This is the basic function. I hope you might be aware about this thing. So let me go to the next slide. So where you can see this is our alternator which is placed on the engine crank shaft, and this is your belt which you have seen already, and this is your alternator position, this is your battery, and this is the voltage regulator. So voltage regulator is always an integral part of the alternator. You will not get the separate, that you have to put the voltage regulator separately. It is an integral part of the alternator. So if you see the connection of this alternator, so this alternator has connection through the first is belt to the engine crankshaft. And you know why it has the this particular connection, because it has to be rotate, and once it will rotate then it will generate the electricity. And the support of the belt, so belt is also plays a very critical role when you are defining the alternator specification. We will see in coming slides. Let me erase. So first is the belt, then alternator position is here, then it has the connection to the battery. So as I already told you, the why it has the connection to the battery, because it has to charge the battery. Then you have the fuse and fusible link, which is used, or charging relay, which is used to protect your circuits, right? Then you have the voltage regulator. So voltage regulator is a part of alternator, as I already told you. Then ignition switch, which is used for the starting the vehicle. This is the one thing. And then indicator light. So indicator light is nothing but it is showing that whether your battery is charging or not. So it will show here this particular symbol if your battery is not charging. If your battery is not charging, there might be many cases, right? Your connection is loose, your alternator is not working, your voltage regulator is not working, or your pulley, this particular belt, which sorry, this particular belt is not properly tightened. We will see all these options or the conditions where we have this type of issue. So this is kind of alternator which all the OEMs are using, and this is the basic design flaw of the design of the alternator. I will not go into the details of alternator construction. You can see the basic things here. So first is, this is nothing but the rotor. Then second one is your exciter winding. Then third one is your stator. uh, then fourth, sorry, stator winding is this one, and this fourth one is, this is your stator. Then fifth one is your collector rings, and sixth one is your the brushes. This plays very critical role, brushes. We will understand this once we will discuss in detail. Then rectifier diode, this is nothing but the voltage regulator which we are discussing here. And this is your B positive and B negative. B negative and B positive, these are the two terminal which will be always be there in any type of alternator. Alternator might be different. Okay, we will see the different type of alternator, and that is the need of defining the alternator specification and how the product development comes into the picture. So we will see those things, but as of now you understand these two terminals, battery positive, this one, and battery negative. These two terminal will always be there in all the type of alternator, where alternator is going to connect to the battery positive, and this is for the grounding. So moving to further, so alternator, we will try to understand now that how this alternator has the different operation in the car. So here I will take the two cases. So first case, where the engine is off, or you can say engine is not running, or engine is slow. You can say this also, it is not running at the desired, you can say desired RPM, right? So we will discuss this thing. Then when it will start generating, it will not start generating electricity at any RPM. You will rotate this, it does not mean that it will start generating the electricity. It has to uh, keep some minimum RPM, so that it can generate your voltage or output. Okay, let me erase it. So when engine is off, then what will be happen? Your alternator will be off, right? If your alternator is off, then there won't be any charging, right? Then power supply to the loads will not be also there, because alternator is not generating the supply. Then what is the source of the power in your vehicle? That is your battery only. So whatever battery is charged, okay, that will supply to the electrical loads. One thing you have to remember here. So what is the basic principle of alternator? So let me raise one time. So basic things you have to understand. So current will flow from one point to, suppose, A point and B point, right? So from this point to this point, if current is flowing, right, what does it mean? Here the voltage will be more compared to here. Here voltage will be less. So suppose if I have that voltage here 11.2 volt, and here is also 11.2 volt, then my current will be zero. No current will flow. I hope this basic understanding you will be having, that what is the basic thing to flow the current in any circuits. So this is the line which is written when alternator is alternator voltage is less than the battery. Okay, and it might be due to any cases, right? Engine is slow and not running. This is what we have taken that. The direction of current flow is from battery to vehicle loads, from here to here. Okay, this is the current direction. Now you can have one question, right? So battery has the connection to alternator as well. Okay, battery has connection to electrical vehicle loads through the fuse boxes. If you are not aware about how these connections are made, I have created uh, many videos where I have shown you how this battery, electrical loads, and alternator or generator is connected with each other, and how the current will flow. You just go through those videos. I will give the link also in the description as well, so that your basic understanding uh, will be concrete, right? So the first question, that the battery will give the current to the electrical loads, this is understood. But the second question also should comes in your mind, that battery has the connection to alternator, and battery will give the, because here, as I told you, here the voltage will be zero, right, when the alternator is not working, right? And here it would be the 12 volt, right? If you are using the 12-volt battery, it would be 12 volt. If you are using the 24-volt battery, it would be 24, right? So then current will start flowing this direction. But the alternator diode prevent this current flowing into the alternator. This is the one thing which you have to understand. So many of our subscriber ask that, can you please give us the interview questions? So these are the interview questions, right? So interviewer will ask, in this type of condition, when engine is off, then what will happen? Will battery will give the current to the alternator or not? Or how the battery is supplying the current to the electrical loads, right? These type of questions only will be asked. This is your alternator, if you see here, this is your alternator, this is your battery, and this is your electrical loads. There might be many, right? Motor components, electronic components, right? Energy storage, that is nothing but the battery only. Okay, so this is the case one. I hope the case one you understood how your alternator is working here. Now we will move to the case 2. In case 2, what happened then? When engine is on means engine is running. When engine is running, your alternator pulley will also start rotating, right? When your alternator is on, when engine is on, alternator is on, alternator is on. When alternator is on, then it is producing the voltage, right? And it will charge your battery, and it will provide the power supply to the load, right? When your alternator is on, then battery will not provide the volt supply to the electrical loads, okay, except some of the deviation. Suppose some of the functions are very critical, and where we have given the connection to the from the direct battery, then it can provide. But always it would be that alternator is providing your supply to the electrical loads. This is the basic function, and this will always work in that when alternator output is greater than the battery voltage. So if I ask you, the alternator voltage would be 14.2, sorry, plus minus 0.2. And what is your battery voltage? That is, sorry, 12.0 volt, right? So your alternator is output is higher or greater, then your current will flow from this to this direction. I hope you understand this thing. Let me raise one time, and I will say again. So alternator output is 14.2 plus minus 0.2 volt, right? Your battery voltage is 12 volt. Then your current will flow from this direction to this direction, and your to the electrical loads as well. So this is the basic function. And if you are working on the 12 volt, then this is the alternator output. If you are working on 24 volt, it's double, just a double. That's all. So I hope you understood the alternator operation in the charging system, how it works and how it is working in the different operations. Right? Now moving to the next one. We have talked about the alternator, we have talked about the battery. Now different types of load. So see, there are different types of load in vehicle, and they might be categorized in different way. So these are the three ways where we have defined these loads. So first is the permanent load. So permanent load, as it name suggests, So these loads are always used or always used when your engine is on. It means that alternator need to provide the power or supply to these load at all the times. Okay, so that like ignition, like fuel pump 50 to 70 watt, fuel injection 70 watt. So these are the typical value of the load requirement. It might be vary from one vehicle to other vehicle. It depends on what type of fuel pump, what type of fuel injection is you are using, right? Even if you see the headlamp, so for one OEM might be different. So for one OEM I am using 60 watt, but in other OEM itself I am using the LED lamp, so they might be working on 12 to 14 watt itself. That might be the case, but these are the typical value which I am telling you as a example. The second load is the prolonged load. So prolonged loads are nothing but, as this name is suggesting, so loads which are used for the long period of time, such as headlamp. So headlamp are used for the longer time, right? Car radio and so on, like heater, tail lamp, parking lamps, and you can see the typical value of the watt power requirement. So 60 watt, 10 to 15 watt for the car radio, heater and AC 60 watt, then panel light for 2 watt, nameplate 10 watt. So these are the watt requirement for the different loads. Then intermediate loads are nothing but where you need the power for very short times, like horn. So you just press the button and it just blow and then it goes off for the millisecond or seconds, you can say, right? So these are the loads where you require the power for very short time, like turn lamp, stop lamp, power window, radiator blower, wiper, horn, starter motor also, cigar lighter, ceiling. So see, starter motor can vary from 0.8 to 3 kilowatt. It depends, right? What type of engine you are using, how much minimum revolution per minute is required. So these things can vary, but these are the typical value you can take as a reference. Cigar lighter 100 watt, then ceiling lamp is 5 watt. So these are the different type of loads. So now question comes, why I am telling all these loads and what is the important to know this. So when you select your alternator rating, right? So suppose your alternator is 55 watt or sorry 55 ampere, 90 amps or 125 amps. So how you decide this rating? So there might be some factor, right, to decide these rating. So you can see in this table I have given example, as I told you already, that these are not the exact value we will take when we will do the product development. We will start this from zero and we will take one example that what how much alternator rating is required for how many loads. So we will take those things. So I'm giving right now a brief overview how you have to go forward. So first, in this table, connected loads duty cycle is nothing but, suppose in 1 hour how much time you want to on that particular load. Then equivalent loads, what are the for the day and what are the for the nights, and then it is required, what is the required one. Okay, so first column is loads, then number of loads in watt, day percentage, night percentage, day equivalent load and night equivalent and required one. So first we will take like horn. So you know that there are two horns, one low frequency horn and high frequency horn, left or right side. The number of load will be 2. Loads what? 42. Okay, this is typical value I am saying, right? Then you are taking the in a day also it can the person can use, and in night also but the person can use. So we are taking 2%. Okay, in night also 2%, right? So suppose if I'm taking the equivalent load for this one, let me erase one time. So 42 into 2, 100 into 2, what will come? It will come 1.68. You just calculate this thing for day also and for night also. One more example I take just for your understanding, headlamp beam. Okay, headlamp beam is sorry, headlamp high beam, one example we are taking. So one is in the left side and one is in the right side, so number of loads will be 2. We have taken the example like loads in 55 watts, we just taken randomly. Then day percentage would be 0, right? No one wants to use in the day time, right? So that's why we have taken the 0%. Then in night we have taken the 100% this cycle. Okay, so if you calculate that 55 into 2, because it is 100%, then 110, the required load is 110. So this is how you have to calculate the equivalent loads to calculate the alternator rating. So these are the different loads where you have to calculate this calculation. So I hope you understand the basic thing. So one example I am taking, like suppose total watt required is 610 watt, right? Total current requirement at 14 volt, 14 volt is nothing but our alternator output, right? So this would be 43 amps. Okay, then we will try to multiply all other factors and we will see how the alternator rating will come. Okay, this 43 is not the alternator rating. I have just told you about the electrical vehicle loads calculation. Now you will be having the battery is also required, so, right? Battery charging is also required, right? So that also need to be added here. So we will see this calculation when we are doing the product development. But as of now, you just understand this thing, how to calculate this particular alternator, ratings. We will discuss this in detail when we will be discussing about the product development. Then as you can see in this slide, okay, we are using the two types of alternator. I have already shown you. So this B positive and this negative, this will always will be there for alternator, but this particular connection might be different or vary depending on the alternator or depending on the project requirement. So here suppose I want the two input from my alternator. One is the charging lamp, charging lamp. So charging lamp for what? So I want to show in my cluster that my battery is charging or not. So I will take one particular connection from here. Then second one, I want the RPM also. Okay. So RPM of this particular alternator I want, or vehicle also you can calculate, because of the pulley ratio you can calculate the rpm of the vehicle as well. If you do not have the vehicle speed sensor or some other sensor, then rpm also can be taken from the alternator as well. So suppose these two connection I want, so I need only the 2 pin connector here, I do not want the 3 pin connector, right? So similarly, this is the one more example. Here only you need the battery positive. This is the voltage regulator already known. This is ground, and this is the one which I need for the charging lamp on the cluster, which we have seen earlier also. Sorry, this one, this one I am saying. So for this, for to showing this particular telltale, we call it telltale on the cluster. I need one connection, and this is the one, that particular connection. So I need here only one connection. So if you see overall, specification, so it is varying based on the project, and that is how this product development comes into the picture. Okay, on what type of project, what type of alternator you require, what type of connection you require. Otherwise one alternator made and everyone is using the same alternator, right? But this is not the case. I need two connection, but other OEM needs one connection only, because they are using the for for frequency or for rpm they are using the vehicle speed sensor, but I do not have the vehicle speed sensor. I have to take from the alternator only. Sorry, I hope you got the concept what I'm trying to say here. So here suppose I'm taking here engine on signal also, charge indicator control also, generator field duty also. So I am using the 4 pull connector here. So I, as already I told you, these two connection will remain same in all the alternators. Okay, one is battery negative and this is the battery positive. Okay, battery positive to charge the battery, and battery negative is nothing but to ground this your whole system, right? This charge indicator also most of the OEM use this charge indicator, this one. Okay, but other thing like RPM or some other voltage sensing or some ECU, sometimes ECU is also want to take the input from this alternator to analyze many other things. Okay, so in that condition your connector might be different. Okay, so how to define which alternator I need to use for my project? To decide the alternator requirement, we need to define the product specification, and defining the product specification start with the product development. I hope you understand what I'm trying to say here. Okay, if still you are not getting why product development is starting, because I need one particular one particular product for my one particular project. I do not want the same alternator for all the project. So you can see here the different K1 B0 K1 type, K1 plus VP, then KCV. Okay, one more thing, if you see here, this is a multi poly, we say poly V belt. And if you see here, this particular pulley is nothing but a single V belt. Okay, so how to define whether I need the poly V belt or I need only single V belt, right? So to define all these things, we come to the product development. So if you see here, the operation of alternator is only permissible in assembled regulator. Okay, connected with battery system. Alternator mounted is directly on the engine block, which we have already discussed. Then mounting used must be rigid and guarantee a ground connection to the alternator housing, of course. Then alternator has to be driven by V belt or poly V belt directly connected to engine crankshaft. So this is required, but V belt or poly V belt, we have to define this thing. Then tensioning of the belt can be performed manually or by a separate auto belt tensioner. Okay, the tensioning of belt is also plays very critical role when you are saying to generating the output of the alternator. We will see this. Correct alternator operation can only be achieved when specified direction of rotation and belt tension is maintained. Incorrect belt tension can damage the bearing and lead to internal eccentrics rubbing, damaging the alternator. Special attention to be paid when alternator used together with other system. So these are the things or do's you have to do when you are doing the alternator product development. So all these things we will see in alternator product development. So here also the same thing, that alternator can be divided AC alternator, DC alternator, then self excited, separate excited, then series shunt compound and compound shunt. Then in regulator also you have mono, then multi regulators. So which type of things you have to use in product, we will define in this product development chapter 2. If you like the content of this video, please like, subscribe and comment. The same thing here we have given that there are different terminal, but which terminal we have to use, that we have to define. So in chapter 2 I will discuss about the technical specification to develop the alternator for the supplier, because supplier is the one who is going to develop that particular alternator. We will discuss about who are the supplier and what they are developing. So this particular document can be said SOR, SOW. We will see this thing, what we have to write in this. Then we will discuss all these things, what is the document scope of the supplier, operation of the component, you know then circuit integration, operating condition, then complete work plan for the project, projected volume. We will see, we will discuss in detail mechanical requirement, vehicle coordinate, drawing prerequest, 3D packaging, CA simulation, what are the manufacturing requirement, weight target, all these serviceable available market target to the supplier. We have to define what is the requirement of proto parts, tooling needs, requirement of inspection, surface quality appearance, shipping requirement, DVP. validation requirements, supplier MOU. We will go till the technical sign off with the supplier. Okay, we will discuss all these things, DVP and other things. If you like, and if you want the second video on product development chapter 2, please like, subscribe and comment. If I got the 100 like on this video, definitely I'm going to come with the product development chapter 2. Thank you for your time.